Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This is an E2 elimination reaction of a cyclopropane ring bearing a quaternary ammonium leaving group, NMe3+. In E2 eliminations, the base, now it, abstracts a beta hydrogen that is antiperiplanar to the leaving group, and the Hofmann type or Zaitsev selectivity is governed by stereochemistry and the available beta hydrogens. Step 1. Identify the substrate. The molecule is a 1,2,3 trisubstituted cyclopropane. Actually, the ring bears 4 substituents, making it a 1,2,3,3 or 1,1,2,3 substituted cyclopropane. Reading the Newman circle projection, 1 carbon, C1, carries H and H, 1 carbon, C2, carries PH and Me, 1 carbon, C3, carries PH and NMe3+. So the ring is C1, H, H, C2, PH, Me, C3, PH, NMe3+, with C1 also bonded to C3. Step 2. Determine the leaving group and available beta hydrogens. The leaving group is NMe3+ on C3. The beta carbons are C2 and C1. Beta hydrogens available, C2 has no H, it bears PH and Me, C1 bears 2 H atoms. Therefore, elimination must occur by abstracting one of the H atoms on C1, giving a double bond between C1 and C3, since NMe3+ is on C3. Step 3. Apply antiperiplanar, E2, requirement. For E2 on a cyclopropane ring, the H and the leaving group must be anti to each other. From the Newman-style drawing, the H on C1 that is anti to NMe3+ on C3 is available, making C1, C3 the bond that becomes the double bond. Step 4. Determine the alkene product. The double bond forms between C1 and C3. C1 originally had 2 H atoms. After losing 1 H it bears 1 H. C3 originally had PH and NMe3+. After losing NMe3+, it bears PH. C2 is still attached to C1 via ring opening. Wait in cyclopropane ring opening, E to the ring opens. The 3-membered ring undergoes elimination to give an alkene, C2C1 is equal to C3 connectivity. C1 bears H and bond to C2's PH Me side, and C3 bears PH. So the product alkene is C2PH Me is equal to C1H with a bond from C12. Actually, for cyclopropane E2, the C bond of the ring between C2 and C3 breaks, the 1 beta to leaving group and alpha to the H being abstracted, giving an allyl type alkene. The product is PH Me C is equal to CH PH, which matches option CPH and Me on one carbon, H and PH on the other carbon of the double bond. Step 5. Why other options fail? Option A requires 4 pH groups total, but the substrate only has 2 pH groups. Option B requires 3 pH groups. Option D introduces an OH group from the solvent which does not occur in simple E2. Only option C accounts for both pH groups and the Me group in the correct arrangement. Therefore, the correct answer is C. Therefore, the correct answer is option C.